All right, what's up, everybody? So we're going to be doing this assignment today in a whole new way. I'm kind of working my way through this with my touch screen here, the Surface, so it kind of makes doing this stuff a little bit nice. But let's walk through this assignment. I know a lot of you guys have been struggling with this kind of stuff, so I'm going to try my best to help you out. Okay, so on my assignment, I said, hey everyone, hope you're doing well. I have a little range of problems for you to try. Basically, what these 3 problems are going to do is I'm going to try to build you guys up to doing stoichiometry. And I understand this is difficult, so if you guys are struggling with this and you can't do it on your own, just wait for my videos and do them with me. So if you walk through them step by step with me, you write them out on a sheet of paper, take a picture, email them to me. You can turn them in through Google Classroom. Either one of those options really works well for me. And let's say you can't even do that. Let's say you're like in Google Classroom, but you're having trouble submitting. I know some people have had trouble submitting assignments. You can just write this down as you're watching these videos that I'm posting to YouTube. Take a picture, and you can even text them to me. If you I've had students text me pictures of their work before, and I'll accept that as well. So if that's you and you find yourself in a special circumstance there, you know, just let me know through email. You can even contact me. Well, I guess email is probably the best way. You can call me at school if you want. Again, my phone number is 906-396-8086. If you have any issues, feel free to give me a call. I'll be here probably usually from noon to 4 is when I'm in my office and working on this stuff and trying to come out with stuff for you guys. And just let me know if there's any way I can help you. So I'll walk you through these videos, and if at the end of them all you've managed to do is copy down everything and you're trying your best, you know, you're still going to get a good grade for this. I just want you guys to try and learn, and hopefully by mimicking what I'm doing, you'll eventually understand what it is I'm doing, and you'll be able to move on. So first thing I got to do here is I got to select a color. So let me see how I want to do this kind of thing. We don't want to do text highlighting. Ooh, let's go with blue. There we go. No idea how to, oh boy. So learning how to do this kind of a thing. Yeah, we'll just do this. Okay. Back. Okay, sweet. Cool beans. All right, so we're on to the good things here. Let's make sure my size is okay. Let's go ahead and do, 2 should be fine. Okay. All right, let's get started. So the first thing I had to do is balance equations. So remember that, you know, the 3 laws. One is that things basically seek equilibrium, right? Or balance. It's this idea of balance in with energy and with basically everything in the universe. Is that all things seek an equilibrium or a lower state, right? So that moves into our next one, high energy to low energy, or you can think of, you know, balance. Like it's another thing. Like if I open up a room and I open it to the outside, that hot air is going to want to move towards that cold air because the hot air is higher energy. We're going from high energy to low energy. We're seeking equilibrium. And then also remember, you are not a wizard. So basically, the 3 laws there, you can't create or destroy energy. Things seek balance and equilibrium. Okay. And I think I'm forgetting something in there, but we'll move on from there. So this is basically the application of the you are not a wizard concept. So that's one of my favorite ones. All right. So balancing equations. What we have to do is make sure that our number of iron here, or ferrous, is going to be the same number of our chlorine here, Cl. Okay, now I can't write those in subscript on Google unless I put them in there as a picture, and that just makes things complicated. So I put stuff in parentheses for you guys. That way you can tell if I'm going to be multiplying it by a number outside of it or not, and I'll always try to be very explicit with that. And if I get too complex or I am not clear with how I'm writing it, just let me know. That being said, let's get started here. So let's move back. All right, so now I got my pen. Okay, so now we have iron and iron here. Okay, so 1 to 1, that's fine. But we have 2 Cl and 3 over here. Well, if we just take these numbers, 2 and 3, and we multiply them by each other, we get a common factor. So 2 times 3 is 6. So how do we get 6 over here? Well, we have to multiply it by 2. Oh boy, that's not clear at all. Learning is a process. Oh yeah, erase that whole thing. Sweet, I'm a wizard. All right, let's try the pen and let's try zooming in real far. Okay, so now we're cooking with gas here, folks. So let's go 2. All right, so we got 2 there. 2 times 3 is 6. We need a 3 over here then, so let's zoom in there and write a 3. Oh, my penmanship is awesome. If my second grade teacher could see me now, she'd be so proud. All right, so we have 2 and 3. And if we have 2 iron over here, that means that we have 2 iron over here. All right. So now at the end of this, I need to make sure that I am not a wizard. All right. So first thing, am I creating or destroying any molecules? Nope, because we have 2 iron and 2 iron. Okay, what about chlorine? Well, I have 3 times 2, and that is 6. And then we have 2 times 3, and that is also 6. So there you go. You're applying your math skills that you learned with, what's that, factoring, right? Yeah, I think it's factoring. And there you go. And if you guys are struggling with this, just practice. I mean, it really does. It takes a lot of practice to kind of ingrain this in your brain. I can't tell you how many of these I've done over my lifetime. I think we used to have like 10 worksheets to do in my chemistry class in high school, and that made me cry a lot. So if you guys want to get really good at it, I'd advise trying to do that and then looking at the correct answers. There's tons of stuff on the internet nowadays, and I can always provide you with a whole bunch of different worksheets if you're looking for that kind of stuff. So if you're struggling, let me know. I can give you direction on how to practice, and yeah. And so let's take this next one. Now this next one gets a little bit more difficult here because instead of balancing one thing, we're balancing like a lot of things. Okay, so one of the first things we got to look at here is we have SO4, which is a polyatomic ion. So if you still have that pink sheet, which is actually hanging on the wall behind me too, SO4 is a polyatomic ion, and we're going to be combining it with iron, and we're going to be combining it with H2. Okay, so we're going to treat this as one atom. Okay, and then we have HBr. Okay, now we already know we're going to need some additional H's here. Okay, we have a Br3, Br2. Now none of these are going to be simple. So what I like to do with these is I kind of like I make like a little chart, and I usually do like a little T thing. So let's see if I can. Oh boy, oh, didn't mean to do that. Yeah, go on. There we go. Erase that whole thing. Yeah, that's awesome that it does that. I'm so excited about that. Okay, so let me just zoom in super far here. That way I can write this out and my handwriting will look neat. So we have F, E, right? And let's go down, create a little line, and we have F, E on this side. And I'm just going to write little numbers kind of like off to the sides of these and make sure they balance. Okay, and this will kind of help me track as I go through this. And this is just my own little method. You can do a little T thing right here because you can imagine this arrow as being an equal sign, and everything has to be equal because you cannot create or destroy energy, right? Or atoms. So you're not pulling stuff out of the sorting hat, doing any cool stuff like that because you are not a wizard. All right, so we have iron, and we have Br. So Bro. Let's go. That's a really terrible R. Again, I apologize for my penmanship. It's been a struggle for very, very many years. Okay, so there's BR. All right. I used to have a pen for this where I could actually write it out with like a pencil or something, but kind of lost that ability with losing the pen. And they want $50 for a new one. I'm like, there's no way that's happening. But you know, because I'm totally spending that money at Subway or something. All right, moving on. So let's take a look at these ones first. So I have Fe, and then I have 2 Fe over here. Okay, so the very bare minimum, I'm going to have a 2 in front of this. Okay. Now let's look at the iron. So we need 2 iron. SO4, 3. So it's having 3 over here. Okay, so we know for a factor. We know for a fact that we're going to need at least 2. So let's start by doing that. Let's tentatively put a 2 in here. Okay, so I think we're zoomed in enough. Let's see if my penmanship skills are there, and they are. Nice. Okay, so we have 2 iron, and we have 2 iron over here, which is nice. So we can write a 1 here. That's just a placeholder for now. And then we have a 2 over here. Okay, so 2 and 2 equals, they're equal across this line. That's what's really important. So next, we look at our BR, and so our BR has to be the same. Okay, so I'm going to go ahead and slide over here. Oh, we need 3 of those at least. Okay, so we have 3 over on this side, which is a little, that should be subscripted. We can just imagine that's lower. So that's BR3, so we have 3 on this side, and we need to have 3 over here, so we have to multiply this by 3. Let me get that. Oh yeah, that's art and it's purity right there. So we have 3, 3. Okay. Now we're probably gonna have to do some wizardry here in a second, but I'll talk about why we started where we did. Okay. Now we have 3 hydrogens. Over here we have 2. So we have to multiply this by a factor of what? Well, it'd have to be to get that to balance. We have to multiply that by a factor of 3. Okay. So 2 times 3 is 6. We multiply this by 2. Okay, so everything on this whole side has to be multiplied by 2. So now instead of 2, we have 2 times 2. So let me just explain what I did here. All right, so I have 3 hydrogens. I have 2 hydrogens here. Well, 2 times 3 is 6, okay? So now for all of these, I'm going to have to multiply everything else that I've done so far by 2 in order to make it balance, okay? Because we're trying to find just the bare minimum numbers that will work, and then we can always reduce down. So I'm not sure if I'm explaining this well enough, but let me go back and explain what we did and see if we can move forward here. All right, we have 2 iron, and we have 2 iron, and we have 3 bromine, and we have 3 bromine, but we have 3 hydrogen and 2 hydrogen, so that's not working out. So what we need to do is multiply this by the number that's here, and then take this number that's right here and multiply everything else by it. Okay, so what we're basically doing is, because this thing right here doesn't match up at all with everything else, we take this number right here, that would be our lowest common denominator, and multiply it by this one, and that will balance this all out. So let me just explain, or let me walk through this, what we're going to be doing. Okay, so erase that. Nice. That's actually working surprisingly well. Very happy with that. Nice. All right. So let's go back to my pen. All right. So to start with, we had 2 in front of here. Now we're going to multiply it by 2. So let's start with 4. All right. So we have 4 iron. That means we have to have 4 iron over here, which means we have to multiply this by a 2. Now, 2 times 3 is 6. So we have SO4. Okay. So now we have a total of 6 SO4. All right. Oh, this is gonna get interesting. So now we have 6 Br. All right. 6 HBr, and we have multiply this by 3. Alrighty, now let's see if this balances out here. So we have 4, 3, 2, 6. Alright, and we know, like, typically, you know you've reduced it down enough when you get something like an odd number and then the rest are evens, because you know that one odd number is messing everything up for everybody else. Alright, so that would be like saying SO4 times 3. We have SO4 times 3 here. All right. Now our issue is that we have 3 of these times 2. Okay, so we might even have to go even higher here for this one. Okay, so that's not working out. A lot of this is trial and error, guys, and that's kind of what I'm trying to get at here, is you have to do your own system. So we know that's not working. We know that's not working. Let's see. Well, let's see if we can come up with a ratio here. So what it seems to be doing right now is, for every 2 iron, we are going to need 3 SO4. So let's try doubling this number. Let's try going 6 here and seeing if that works out. So if I have 6, all right, now I have 6 SO4. I have 6 SO4. I have 12 over here. I have 6 times H, which would mean I'd have to turn that into a 12. All right. So now I have 12 HBr. All right. What am I lacking? Well, let's see if that balanced out. So I have 12 HBr. 4 times 3 is 12. So we have 12 here. 12 to the left. All right, there we go. Thanks, Beyonce, for that little nifty bit of advice. And 4 times iron. So we have 4 iron on that side. All right, for hydrogen, we have 12 hydrogen. So let's go ahead and do a best letter ever right there, H. All right, so there's 12 hydrogen. And then on this side, we are also going to have 12 hydrogen. So we did 12, 12. We're pretty well balanced. All right. Now we have 6 SO4. We have 6 SO4. I'm not going to write out SO4 here because if you have everything else balanced, it should all work out. So let's see. 2 times 2 is 4. We have 4. That's a really bad looking 4, but it is there. All right, it doesn't have to be cute. It just has to be functional. So BR, 12 times BR is 12. All right, there we go. And we 12, 12. And can we reduce any of this? Ooh, it does look like we could reduce it. So what can we reduce this by 2? All right, so this is where the trial and error thing comes in. So we could say we have one of these. So it'd be 1, 6, 3, 2 is what we're going to have. So we just divide everything by 2 and we get our ratios. And then let's see if that would work. All right, so a lot of this is going to be trial and error. But if you realize these have a common factor like these ones do right now, then you can go ahead and reduce them all. So let's start by going, let's see, 2. All right, how many of those do we have? We had 6. We're going to go 3. Okay, and then for the iron, we need a minimum. Okay, so we'll say 1. And then HBr, how many of those do we have? We needed 12, so 6. Huzzah! All right, we did our thing. So we have 2, 3, 1, and let's multiply that out and see if that works here. So we can use this little chart to help us. This tool has gotten so much better since when I first got this computer, guys. I really got to say, technology is awesome. And I'm not saying that because I want to someday go to the moon, but like, you know, that'd be cool. All right, so moving on. So 2 iron. All right, 2 iron. Okay, and then 6 hydrogens, 6 hydrogens, 6 bromine, 6 bromine. And a SO4 is 3, SO4 3. Awesome, we're all balanced there. So now we can go ahead and get rid of this whole chart in here, and that is so neat that it just selects it all like that. That really just makes my day. So your final answer should be 2, 3, 1, 6. All right. I'm probably going to cut this video off after doing the balancing equations part. Otherwise, it'll probably take like 30 minutes, and you guys are going to be just sound asleep in your chairs. So let's go ahead and take a look at this C7H16. All right, there we have a hydrocarbon. Okay, and you can probably figure that out which one it is because it's going to be 3 at each end, and then you can figure out if it is fully saturated or unsaturated. And we're combining with oxygen, which means we're doing really cool things like starting fires. Only in controlled environments, so that's the only reason why they're cool. So we have C7H16O2, and that's going to make CO2 and water. And this is a combustion reaction, so we just have to balance this out. So really, we just have to, the thing I like about these kind of equations is like we have C7, so we naturally have to have a 7 over here. All right. So if we have one of these, well, now we know we have 7 of these, so 7 times 2 is 14, so we need 14, so we got to put a 7 over here. Okay, and then how many hydrogens do we need? Well, we somehow need to get 16, so we have to multiply this by 8. Okay, and we're going to actually hold off on doing this one just yet. I'll go ahead and get it out of there. There we go. Okay, so let's take a look at this. We have our 7 carbons. Oh, that's accounted for. We have our 16 hydrogens, and that's accounted for. And finally, we have to account for our oxygens. And you're like, oh, how many oxygens will we have? Well, there's 14 and then 8. So 14 plus 8 is going to be what, kids? It's 22. There we go. Quick maths. So we have 22 there. 22 divided by 2 is 11. and you can't write with an eraser. All right, so there we go. There is 11. All right, so real quick for combustion reactions, and I don't know if you guys saw what I was doing there, but the first thing you should always do is look at the carbons here, and then just go ahead and write that factor right in front of your CO2. Makes it super quick, super fast. So you take that 7, that's by the C7, and you just put it right here, and then just balance or write out the right side to balance the left, and it'll work out beautifully. So what do we do next? Okay, so now we have our 7 carbons. How many hydrogens do we have? Well, we have 16 hydrogens over here, so we have to multiply this one by 8. All right, and then finally the last thing you go for is the oxygens on combustion reactions, and that is my favorite way to do these, and it will save you a ton of time. Okay, I don't think I've ever seen anybody do this in a YouTube video before, so you can go ahead and give me all the credit for this. Okay, again, what do? You look at the number of carbons, write that number right in front of your CO2, and then you balance your hydrogens. So 16 hydrogens over here, you have H2O. All right, H2, 16 divided by 2, you write 8, and then you go ahead and balance your oxygens last, and it will save you a ton of time. Okay, so hope you guys found this informational. Hope it helps you guys out. I'm going to make sure and check all my answers with a variety of keys I use for this. All right, make sure you write your 1 there. Yeah, so if you guys have any questions, hit me up on my email. You can shoot me a text, do whatever, give me a call. I can walk you through different problems, whether it's through Zoom or whatever you need. Yeah, I miss having you guys in class. I hope you're doing well. Hope you're understanding this stuff. I hope you understand the balancing part. This is basically applied algebra, so this is why learning algebra is important. And yeah, tomorrow I'll tackle this part, the converting molar masses. That one will probably take a little while too. All right, so we're going to wrap this up, and have a great day, guys. I'll talk to you later.